Okay, so how many terms do we have in this sum, guys?
N.
N, right. And when n tends to infinity, having n terms, we will have infinity many terms at the end, so it's not so easy to find the limit. So we do not need here to find limit of each of these terms separately. So do you have any suggestion how we can solve this exercise?
Telescopic theorem.
Yes, let's try to apply telescopic formula here. The first term can be written as 1 over 1 minus 1 over n plus 1. Am I right?
But times 1 over n.
Right. It is not correct if we bring it a common denominator. We will find m on numerator. In the beginning, we have 1. So to make it correct, we have to multiply with 1 over m from the beginning. Okay. The second term can be written as 1/2 minus 1 divided by m plus 2. Next term, 1 over 3 minus 1 over m plus 3, etc., etc. And then at the end, let me write the last two terms and we will discuss. So the term before the last one is 1 over n minus 1 plus 1 over m plus n minus 1. Sorry, we have to write minus instead of plus. So here we have minus. And then the last term is 1 over n minus 1 over m plus n. Do you agree with this? I hope so. Yes. So let's move forward. Next step is to cancel terms if we have such. So we have 1 over 1. Do we have minus 1 over 1? We will get minus 1 over 1 if terms this one, or maybe this one, or maybe this one is 1, but it depends on value of m. If m is 0, we might have, but when m is 0, maybe it is not very interesting exercise. 1/2 will be cancelled with some of these terms.
No.
1 over 3 can be cancelled again with 1 over m plus 1, 1 over m plus 2, 1 over m plus 3. So when you said 1/2 is not cancelled, it might be cancelled with the first term if m equals to 1. But if no, then okay. We said, so we have 1 over m. The first term that will be cancelled, this minus 1 over m plus 1. It will be cancelled if you have also 1 divided by m plus 1. Huh? So we have 1 plus 1/2 plus, so we have 1 over 1 plus 1 over 2 plus 1 over 3 plus etc. plus 1 over m. And then I have to write 1 over m plus 1, but 1 over m plus 1 will be cancelled with this negative 1 over m plus 1. The term after 1 over m plus 2 will be cancelled with this one, 1 over m plus 2, etc. All these terms will be cancelled except m term from the end. So we will keep this one, we will keep this one, and we have a similar m terms. M is fixed. Remember, we have sequence dependent on n. N goes to infinity, we have to find limit where m is some parameter. M is fixed. n tends to infinity. So our result at the end will depend on m. So from the end, we are going to write m terms. So if we have like the last one, minus m plus n, the one before that, minus 1 over m plus n minus 1. And I'm going to write another m terms. So this is the first one, this is the second one, and mth term will be m plus n minus m plus 1, if I'm not mistaken. Now, when we have n tending to infinity, what's going on? When n tends to infinity, guys, we have n written here. What is the limit of this one?
0.
It's 0.
It tends to 0. This tends to 0. This tends to 0. So we are going to have only this part remaining at the end. Do we have such answer?
D.
D. Okay, so this is the correct answer. Okay. Another easy way to solve this exercise, guys, is the following. Choose m, 2, 3, 4, some constant. Plug any constant m you wish. And then eliminate wrong answers. When m equals to 2, we have 1 over 1 times 3 plus 1 over 2 times 4 plus 1 over n times n plus 2. This will be very similar to your homework exercise, like standard telescopic example. Then find and solve, and then check which answer will be correct. When you are choosing m equals to 2, maybe we will have several correct answers here. But drop wrong answers. Choose m instead of 2, 3, 4 other constant, and then you can find correct answer. Like I'm giving you another way to tackle this exercise, not the best one. So the best one is just write telescopic formula. And in this case, we are going to have m terms from the beginning, m terms from the end. Last m terms tend to 0. We are going to have just first m terms. This is the short answer. Questions? No. Okay. Next question. 2018 multiple choice number 7. 2018. We choose number 7. Okay. F from R to R is odd periodic function. The period of function is 8. We have some weird function, okay, from 0 to 4. Period of function is 8. It is odd function. Okay, which of the following is true? We have to calculate F5, or maybe the information provided here is not enough. Okay. My first naive approach is this. F5, so we know that this is f of x. Can I say that f at 5 is just 5 squared times 4 minus 5? So just I have plugged 5. So minus 25, should I? circle B as correct answer.
No, we can't. It is not in our domain.
Right,
The domain
because
is-
our function f is defined like x squared times 4 minus x only from 0 to 4. Now, at 5, it is not defined in this way. So what can we do? We can can you help me?
Calculate
The
with
function is odd and
Minus
periodic.
3.
Say again.
Use the
F5.
fact that the function is odd and periodic.
Okay. If it is periodic function, then do you agree that value at 5 is the same as value at 5 minus 8? You can add period, you can subtract period, value of function will be not changed. Right?
Yes.
Of course, adding 8 will be correct, but F13 is not any better than F at 5. But here we have F at minus 3. It is still not from 0 to 4 domain, but as you said, we can also use that the information that the function is odd. Odd means it is minus F at 3. And now finally we have F at point from 0 to 4. So from 0 to 4, our function is defined as x squared 9 multiplied with 4 minus 3. So it's minus 9 and we do not have minus 9, or I did some mistake.
We did this.
But there
we
is a
did,
typo
we did
in
it
this
with our short,
exercise.
and yes, there is
Most
no
probably
type, so-
there's a typo in this exercise. Okay?
No, it's just f at minus 3 equals to minus f at minus 3. I'm sorry. For minus 3, we should plug 3.
Okay, so minus f at 3.
Yes.
And F3, we are plugging 3 here, we are getting just 9.
Oh, okay.
Yeah.
I have another question. When
Please.
when it says that the function is odd and periodic, it doesn't mean that it's odd and periodic only on the domain mentioned here, right? It is.
It is odd and periodic on R.
Oh, okay. Thank you.
So once again, let's check if we did here correct calculation. F5 is the same as F minus 3 since function is 8 periodic, seems to be correct. F minus 3 is minus F3 because function is odd. F3 is 9. So we have to get F5 equals to 9. So most probably there's a typo here, or this is not the final version of the test that we have in
Can
the
we
exam.
solve the 5th exercise also?
Please write it on chat and we will come to that. Hertovan, Kelly. 2024 show work 2 and 3. Okay. This is the test 2024 show work number 2. Calculate the limit of this sequence. How many terms do we have written in this sum?
With n հանած 2 գումարած 1
Երեք
Եկեք հաշվենք, լավ. This is the first term. I'm writing here 1. Then second term. Third term. The next term is going to be 1 over 2n plus ln Short SL, I think this is also not correct exercise. Again, am I right that it is something wrong here?
No, I
was
think it's
thinking-
right because we've solved this.
Okay. Why I'm saying so? What do you think? Okay, now we'll see a bit later. Do you know why I'm saying maybe something is not here? Fine. The last term, the general term, is logarithm 6n.
It should have been 2n.
I don't know.
Maybe the first
Yeah,
two elements are fixed, and then it starts to.
maybe yeah. So something is not correct here. Let's fix it by for example writing instead of 6n 2n.
Sorry, but why it is wrong? We can say that there are 3n terms.
What is x1? Okay, can you say what is x1? When n equals to 1.
1 over 2n plus ln 2.
Yeah, when n equals to 1, so your x1 doesn't depend on n. It should be constant. So n equals to 1, it will be 1 divided by 2 plus ln 2. I don't know. Why so big?
Plus
x1
1 over
plus
2 plus
plus
Yeah.
1 over 2 plus logarithm 4 and then plus 1 over
plus 1 over
2 plus
2
logarithm 6.
logarithm. Yes.
Okay. Then what is x2? x2 is 1 over 4 plus logarithm 2 plus
Have to check.
1 over 4 plus logarithm 4, etc. Plus the last term is when here we have 4 plus logarithm 12. Is this the way that we have defined? If yes, we can assume everything is fine. If this is the case, now, how many terms do we have in xn? Again,
3n.
this is the first term, this is the second one, this is the third one. So this 6 we are dividing by 2 to get the number of terms, and here we will get 3n. So we are going to have 3n terms. Okay, let's keep this.
Question.
Do you have questions so far? We didn't even start the exercise, guys. We are trying to understand what is xn, and xn seems to be sum of 3n terms.
Why isn't there n plus 2 terms in this?
Why 3n plus 2?
Because the first and the second կոտորակներ ոնց որ ունեն առաջին ու երկրորդ ֆիքսված ոնց որ անդամները, դրանից հետո սկսի
Sensor. So my interpretation of this is that the next term here is going to be 1 divided by 2n plus logarithm 8. Then we are going to have 1 divided 2n plus logarithm 10, and etc.
And how did we guess that the next term is 2n plus logarithm 8?
Because we have logarithm 2 here, we have logarithm 4, we have logarithm 6, so it seems that it's moving forward by 2.
Doesn't
just
that,
can say that
Once again,
The
I
last
agree that the
term-
formulation is not correct. Here we have some assumption to do.
Can't we just say that the last term in the logarithm should be divisible by 6, like every 6?
The last one, yes. The last one, yes.
Yes, and that's overly.
Yeah, the last one, yes, but not all of them. We have just
Դրանից
logarithm even
առաջն է
numbers.
բնականաբար դրանից առաջ է դե 6 4-ի հետո է
Չէ, ինչի, մենք զույգերով բարձրանում ենք մինչև 6-ն։ And we have three n terms in this writing. So once again, guys, this is test from the last year. If once again, if I'm not mistaken, here we have a typo, and I will try to find the last version and change this with the last version. Now, let's move forward, guys. Here we are going, so we have three n terms. Now, the goal is to find limit. How we can find limit?
Through the squeezing theorem.
Yes, try to apply squeezing theorem. And to apply squeezing theorem, we have to estimate xn from above and below. Do you have any suggestion for the estimation from above?
Yeah, maybe
The first term, because it's the biggest.
The first term is the biggest because it has the smallest denominator. So the first term is 2n plus log n 2. And all terms are replaced with this. Etc. So we have 2n plus ln 2. What do we get?
Yerek
We have calculated the number term, so 3n divided by 2n plus.
ln2.
What is the limit of this expression?
Yerek
3/3.
Yes, we can just divide both numerator and denominator by n, and here this goes to 0, hence 3/2. Can we say the proof is completed? The limit is 3/2?
No, we need to find it from below too.
Yes.
Right. We have to estimate xn from below. I missed some question.
That was me. I was
Yeah,
asking,
please.
we're solving this problem, assuming that there is 3 instead of 6 in the formula in the last term. There is 2, I'm sorry. There is 2 instead of
Okay.
6.
Okay, but it is not going to change anything here. So once again, I agree that at some point we have to understand what's going on with our, but like even keeping this formulation, for any n, we are starting from logarithm 2 and we are moving to logarithm 6n by step 2. It's fine. It's fine. Like I can define all xn's, like x10 is 1 over 20 plus logarithm 2 plus 1 over 20 plus logarithm 4, etc. up to 1 over 20 plus logarithm 6t. It is well defined. So we can keep like that also. There, but to complete the exercise, we have to estimate xn from below. And help me how we can estimate xn from below.
Taking the last term because it's the smallest.
Right. Doing the same step as above, but now estimating with the last term, which is the smallest term. What is the limit of this expression?
Eli yerek երկրորդ.
Why?
N-ը ընդհանուր ենք անում, N ցկտում է 0-ի, մնում է
Okay.
3.
The last one tends to 0 by useful limit. Okay. So it's 3/2, and then some. We should complete the exercise by saying that the squeezing theorem implies that xn goes to 3/2. This comes at the end. Huh? Questions? If not, let's move forward to the next exercise number 3. Show work number 3 from the same year. Find limit of this sequence. Do you have any suggestion?
We should find the fastest term in the denominator and divide both denominator and denominator by it.
Okay. Fastest term, we have n plus 1 factorial multiplied with 4n plus 2. We have minus 4 times 7n. We have n plus 2 factorial and n factorial times 4n minus 1 squared, n plus 1 factorial times 6n, and 9n. What do you think? what is the fastest term here?
n plus 1 factorial.
N
Or
plus
just
N
1
plus 2
factorial.
factorial.
4
Uh,
times 7n.
So I heard n plus 1 factor, n plus 2 factor, and which one was the last suggestion?
N plus 2 factorial.
Okay, let's keep n
Yeah,
plus 2
okay.
factorial. Okay.
Mhm.
So numerator is divided by n plus 2 factorial. The first term, n plus 1 factorial, times 4n plus 2 divided by n plus 2 factorial. Then we have minus 4 times 7n divided by n plus 2 factorial. And we have 9 times, okay, not just 9. On the numerator, we have n factorial times 4n minus 1 squared divided by n plus 2 factorial plus 2 times. I'm just dividing. Next, you will help me with some simplifications. 6n minus 1 over n plus 2 factorial and plus 3 times 9n divided by n plus 2 factorial. Okay. What is the limit of n plus 1 factor, or how we can simplify before starting?
We can write n plus 2 factorial as n plus 1 factorial times n plus 2.
Perfect.
And then, yeah.
So yeah, n plus 2 factorial actually is n plus 2 multiplied with n plus 1 factorial. N plus 1 factorial can be cancelled out. And from the first term, we will have 4n plus 2 divided by n plus 2.
From
right?
there, we can take n out.
Even without that, yeah, or yeah, we can take n out or divide by n numerator, then numerator. Yeah, we will come back to this term, right? The second, no need to simplify. We cannot, like it's just 7n divided by n for some constant, n plus 2 factorial plus 9. Okay, on the numerator, n factorial divided by n plus 2 factorial. For n minus 1 squared divided by, it left n times n plus 1. Okay? Next term, n plus 1 factorial over n plus 2 factorial. Again, we will get n plus 2 on the numerator. So 6n minus 1 divided by n plus 2. And at the end, we have 3 times 9n divided by n plus 2 factorial. And we are ready to pass to the limits. Okay, what is the limit of this term?
4.
Yeah, it's 4, and as you said correctly, you can write it as, so it is equal to, let me do only for this one, 4 plus 2 over n divided 1 plus 2 over n. And when n goes to infinity, 2 over n tends to 0, here we'll get just 4.
Մենք այս դեպքերում անպայման պետք է գրենք, որ n-ը ձգտում է վերջության դրա համար այդ մասը ձգտում 4-ի։
Like if you have written this blue part, and then
Yes.
limit is 4, here that limit of this form is 4, is not any like need for simplification or justification. 2 over n tends to 0 is straightforward.
Okay.
So like writing like this is enough. 7n over n plus 2 factorial tends to
0.
It tends to 0. Do we need to here refer to the useful limit? No. N factorial is faster than 7n. We have n here. Okay. What's going on here?
16.
Yeah, we can open brackets.
Sorry, don't we have a mistake in this fraction?
Could be.
Shouldn't it be like n
It is,
plus
it
1
is,
times
yes,
n
yes.
plus 2?
Yes. Let me fix
Out of this.
all of this. So let me fix it. It should be n plus 2, okay? Is this correct now? So n plus 2 factorial over n factorial gives n plus 1 times n plus 2.
Out of this.
All of this. So we get 16n squared minus 8n plus 1 is divided by n squared plus 3n plus 2, and limit here is 16. Yeah. This term goes to
Տասներկու,
and the last one
0,
0. So to complete the exercise, plug all these numbers together. So we have 4 minus 0 plus 9, 13, divided by, we have 16 plus 12, 28. Questions?
Էլի մենակ ըստեից ուրախնդրեմ մի հատ եկը բացատրեք այդ n plus 1 factorial-ի ու n plus 2 factorial-ի այդ կրճատումը ոնց արեցիք։
Yeah, we have used the
Got it.
formula that n plus 2 factorial is n plus 1 factorial times n plus 2. Okay, n plus 2 is product of all natural numbers from 1 to n plus 2. N plus 1 factorial is product of all numbers from 1 to n plus 1. So n plus 2 factorial we can write as n plus 1 factorial times n plus 2.
Okay, merci.
Okay.
I
Other
have one more
questions?
question.
Yeah, please.
When we decided to divide both the numerator and denominator by n plus 2 factorial,
Yeah.
how did we come to this? Because I thought that we should identify the fastest term only in the denominator. So how we decided to divide by n plus 2 factorial?
Yeah, because n plus 1 factorial times another n gives n plus 2 factorial. Or n factorial here times n squared gives again n plus 2 factorial, or the order of n plus 2 factorial. So if you prefer to choose, for example, this term as the fastest term and divide numerator and denominator by this, feel free to do it and you will get the same answer.
All right, thank you.
Or if you choose this middle term here, again, you will get the same answer because they both behave as n plus 2 factorial. Huh?
Okay, thank you.
Okay, let's move forward. 2023 multiple choice number 10. Okay, here we go. It's given some inequality, log it 1 plus 1 over n is less than 1 over n, and our goal is not to prove this inequality, but use this inequality. So keep in mind that we have using this inequality, which of the following inequalities can be deduced by induction. The formulation of
Why do we do this by induction? Can't we do it by aren't induction can't?
But statement find the correct answer. It says, imagine we are proving these inequalities by induction. It is embedded in this.
Induction-ով մի հատ պատասխան լինի ու մեր ձևով արած ուրիշ պատասխան լինի։
Ուրիշ պատասխաններ լինեն։
Դաժե տենց, հա։
Փորձենք, եկեք տեսնենք ոնց է ստացվում։ Okay, let's begin from A. Prove by inequality by induction. Ինչ նշանակում։ Assume the base case when n equals to 1, log 1 is less than something will be correct because log 1 is 0. Then we are assuming the inequality is true for some n equals to k, which means we are assuming that logarithm k plus 1 is less than 1 plus 1/2 plus etc. plus 1 over k. Can we prove for k plus 1? Can we prove that logarithm k plus 2 something like this is less than 1 plus 1/2 plus etc. 1 over k plus 1 over k plus 1. Okay. What is given? It is given that logarithm 1 plus 1 over n is less than 1 over n. And we can use it. Now, when we are proving some inequality using induction, or when we are applying induction to any inequality or to any statement, the main point of induction is to make appear the hypothesis. So this is our hypothesis. And when we are trying to prove, somehow we have to use log k plus 1. How we can create log k plus 1 term here? So logarithm k plus 2 actually can be written as k plus 1, right? We can write this as logarithm k plus 1 multiplied with 1 plus 1 over k plus 1. Do you agree with this step? I took k plus 1 into common, so k plus 1 times 1 over 1 plus 1 over k plus 1. So far, so good?
And now we should divide like the logarithms, just make them plus.
Yes, logarithm of multiplication gives sum of logarithms. So logarithm k plus 1 times 1 plus 1 over k plus 1 can be written as logarithm k plus 1 plus logarithm 1 plus 1 over k plus 1. And then we can use the hypothesis because we have already logarithm k plus 1 found here. So by our hypothesis, it is less than, the logarithm k plus 1 can be written, so we are applying the inductive hypothesis. It's less than 1 plus 1/2, etc. 1 over k plus 1 over k. Okay. 1 over k. And also, we have the term written after this one. What can we say about the last term, guys? How we can estimate logarithm 1 plus 1 over k plus 1? Use this information. Logarithm 1 plus 1 over n is less than 1 over n. Then log 1 plus 1 over k plus 1 is less than 1 over k plus 1. So
Yeah.
now we are using this, let's call this asterisk. Let's use this asterisk. And we'll get 1 plus 1/2, etc. plus 1 over k plus 1 over k plus 1. Isn't it what we were trying to get? Log k plus 2 is less than 1 plus 1/2 plus 1 over k plus 1 over k plus 1. So we get this. And it seems that the correct answer is A. But we can hesitate. And we can say, wait, maybe we can do the same stuff and get that B also is correct, or C also is, or D also correct. Let's just see why we can't get the same with inequality number B. I'm erasing this part.
We don't
And-
have one, right? That's why.
Let's see. Yeah, the difference is that we do not have this one, but maybe still we can prove this by induction. When n equals to 1, it's not even clear what do we have when n equals to 1. Maybe we have 1/2. I don't know. Now, hypothesis in this case for B is what? That logarithm. I cannot do back here. Okay. So logarithm n plus 1 or k plus 1 is smaller than 1/2 plus etc. to 1 over k. What can we say about log k plus 2? But before that, again, let's go back to base case. How many terms do we have here?
N minus 1.
When n equals to 1, how many terms do we have on the right side?
Zero terms.
When n equals to 1, what do we have when n equals to 1? We have logarithm. When n equals to 1, we have logarithm. 2 is less than 1/2. Is this correct? We can check. Maybe this is not correct, or even.
Yes.
Is this correct, guys?
I think it's incorrect.
Oh, no, it's incorrect.
Or when n equals
Me
to 2, logarithm 3, is it less than 1/2 plus 1/3?
It's
Obviously, this
supposed
is
to be
not
less
correct.
than 1/2.
Yes, in part B, it starts from 2. And
Yes, but so here we have n minus 1 terms, right? We are starting from 1/2 and ending at 1 over n. It is not like here plus 1 over n plus 1. Here just 1 over n. And this inequality we cannot prove because it is not correct even when n equals to 1 or n equals to 2. It's not correct because logarithm 3 is not smaller than 1/2 plus 1 over 3. Logarithm 3 is greater than 1. And 1/2 plus 1/3 is less than 1. But actually, even here we have worse. When n equals to 2, we are going to have here n minus 1 terms, as you said, right? We have to consider here just one term, just 1/2. So log n 3 is less than 1/2 is not correct. Less than 1/2 plus 1/3 is not correct. So this is not even true. This one also is not true, guys, because when n goes to infinity, what is the limit of logarithm? When n goes to infinity,
Infinity.
it is infinity. But limit of 1 over n is 0. Something that tends to infinity cannot be smaller than something that tends to 0. Huh? And this is quite similar to statement A, but we have inverse inequality here. But if we try to prove by induction, we are not able anymore to apply this inequality because we have to estimate from below, and here we have estimation from above. So this will not work anymore. We cannot prove the, actually, to be honest, this inequality, the last one, is correct. This estimation is correct. But if we try to prove, what says our statement? It says, when you are proving by induction, which of the following can be obtained using this inequality? If we try to prove by induction, imagine we are proving this one by induction, and we are doing the main inductive step, writing n plus 2 as what we did previously, logarithm n plus 1 into common times 1 plus 1 over n plus 1. Then applying formula for the logarithm n plus 1. And then we have plus logarithm 1 plus 1 over n plus 1. And here logarithm n plus 1, yeah, by our hypothesis, we can say it is greater than 1/2 plus 1 over n. But then we have plus logarithm 1 plus 1 over n plus 1, which we cannot estimate from below anymore. Our inequality here given is opposite. So we cannot move forward from this step. So we cannot consider this one. We found A much earlier. So no need every time to, when you found the correct answer, no need to go deep into other statements to eliminate them. Do it, of course, when you have at the end remaining time. If no, move forward. Questions here, guys?
I have one more question.
Please.
In the D option,
Yeah.
isn't this inequality correct only if n is greater than 1? When n is 1, do we have anything in the right-hand side?
When n equals to 1, we have logarithm 2. Logarithm 2 is greater than 1/2 or not?
But can we have 1/2 in the right-hand side if n is 1? We should consider all the fractions
Yeah,
before.
I don't know what is here when n equals, yeah. So if we interpret this, that right side contains n minus 1 terms. Right side contains n minus 1 terms, okay? When n equals to 1, right part contains 0 terms. So logarithm 1. When n equals to 1, sorry, we have logarithm not 1, but logarithm 2. Right? Logarithm 2. Is it greater than 0? Why 0? Because we have to write n minus 1 terms. N minus 1 term when n equals to 1 is 0. 0 term. Or logarithm 3. Is it greater than 1/2? Or logarithm 4? Logarithm 4 is when n equals to 3, we are going to write 2 terms. 1/2 plus 1/3. Is this correct? Yeah, all this should be correct. But once again, our statement is not to find the correct inequality. It's tough. To prove D is not so obvious at this point. We are going to discuss maybe this during calculus 2, not now. But the correct answer is A by induction using this inequality, which also is not so obvious why this is true. This inequality also you can prove. Other questions?
Ես մի հատ կարճ հարց
Ոչ.
կարող եմ տալ, մինչև անցնենք առաջ։
Այո։
Մենք կարող ենք գրել լիմիտ a մինուս b-ն հավասար է լիմիտ a մինուս լիմիտ b, եթե a-ն ու b, եթե լիմիտները գոյություն ունեն, լիմիտ գոյություն ունի a-ում եւ b-ում։
Ֆունկցիայի մասին թե սիքվենսների։
Ֆունկցիայի։
So limit of function, like we have limit fx minus gx.
Yes.
X tends to some x0. Can we write this as limit f of x as x
Minus
tends to
limit.
x0
Mhm.
sense? Yeah, we can do this if and only if limits of f and g are finite. So f, g
Okay.
are convergent at x0, then yes, you can use this.
Can
In
we
general,
use this during
no.
the midterm?
Yes, of course.
Okay, thank you.
Of course, you can do this, but be careful. If you, at the end, you get here infinity, it gives nothing. You should go back and revise your calculations.
Okay, thank you.
Or maybe
Or
limit
about
f doesn't exist,
induction.
limit g doesn't exist. Say again.
Ասում եմ, որ ոչ induction մեթոդով է անենք, էլի ոնց որ պետք ունենք պատասխանը ստանանք։
Չէ, դին սխալ է, դին չի լինում ճիշտ։
Չէ, A-ն է լինում, որ ոչ induction մեթոդով անենք։
Իսկ դին։
Էլի։ Դին դե որ A-ը լինում էր, դին չենք։
Հա, բայց կարող դին էլ է ճիշտ, այդ է խնդիրը։ A is correct, I agree, A is correct, but D also is correct. Imagine now we have first written statement D, then statement A. Առաջինը կստուգենք D-ն ու կասենք ճիշտ է, but it's not appropriate. Love, 2018, multiple choice number 6. F, G, from 3 to 4 interval to R, are one-to-one functions. And the range of our function is 1/2 of F. The range for function G is 2/3. We should find the correct statement. Okay, let's begin. The statement A says F is invertible. F minus 1 composition with G, the image of that. Okay, let's understand what is inverse of F. So if we know that F is from 3 to 4 to 1/2, and F is invertible function, guys. What is F minus 1? 1/2. Bones?
3, 4.
Okay. Now, F minus 1 composition with G actually is F minus 1 at G 3, 4. What is G 3, 4? It is 2/3 interval. So F minus 1 at 2/3. What is this, guys? This we don't know because when function f is from 3 to 4 to 1/2, the inverse, so if function f is from A to B, inverse function goes from B to A. So f minus 1 2/3, we don't know. F minus 1 1/2 is 3, 4. So let's eliminate A. Let's eliminate B as well for the same reason. F minus 1 2/3. We don't know. What says C and G? Now we have something different. G is the invertible function. And we are going to discuss what is G minus 1. Function G is from 3 to 4 to 2/3. So will be nice to, yeah, for C, we have here 2 to 3 interval. What is G minus 1 from 2 to 3?
3, 4.
Okay, so we have F at 3, 4. What is F 3, 4? It is 1/2.
1, 2.
Yes, 1, 2. 1, 2. D is not correct again because G minus 1, 1/2 is not defined. G minus 1 is defined only at 2 to 3 interval. Same here because G minus 1 is not defined from 3 to 4. It is once again defined only from 2 to 3. So the correct answer is E. The main property for this exercise is if function f goes from A to B, inverse function of f now is working
X-ийн
from B
графикээр
to A.
буухан марий таагаар авасар
Буухан
мань
марий.
просто.
Ճիշտ է։ 2024 show work 3 we have already discussed. 2021 show work 3.
Question.
Yes, please.
For example, if we calculate limit and just there is այնտեղ երկու տարբերակ կա, որ մեկը y-ի աստիճան է բարձրացնում, բայց դա ոնց որ ասում են սխալ են հաշվում, դա ոնց որ հենց midterm որ գնենք սխալ կհաշվեք, թե ոնց։
Yeah, okay.
Հանդիպսին, դա Merci.
2021 show work number 3. Again, guys, limit functions are not included in this midterm. We can do the calculation here. We can apply here 3 useful limits to get the correct answer. 1 plus x to the power 1/3 minus 1 over x tends to 1 over 3. Useful limit of sinus x over x. And logit 1 plus x over x tends to 1. So combining 3 useful limits, we will get this. But let's discuss this maybe next week. What change? Our midterm 1 is going to be based on first 5 homeworks. So 6th one is not going to be included. 2022 multiple choice number 3. We are given 2 sequences, xn and yn. Limit of xn is 4, but yn unfortunately is divergent. But still, yn is bounded. Module yn is less than 5. We have to find incorrect statement. Is A correct?
Yes,
Yes.
Why? Why it is true?
because the limit is 4 and it need to be like all the numbers connected or like close to 4.
Xn squared is a subsequence of xn. If sequence tends to 4, all subsequences also tend to 4. In particular, xn squared also tend to 4. What says B? N times xn plus yn goes to plus infinity. Is this correct?
Yes, as n is infinity.
N goes to infinity, so infinity times 4 is a determinate form. This goes to infinity. Now, plus yn. Maybe we have infinity plus divergent can be finite number. It can be, but in our case, yn is not just divergent. It is divergent and bounded. yn is bounded. Bounded plus infinity is
Because of-
infinity. Drop B. The sequence yn plus xn is divergent. Is this correct?
Yes, divergent plus convergent is divergent.
Correct. Divergent plus convergent is always divergent. Xn plus yn over n does not exist. Limit of xn is 4. Yn is divergent. What can we say about yn over n?
It's 0
Why?
By
because n
squeezing.
goes to infinity.
Yes.
It's like this.
Squeezing. 4 plus 0 does not exist. No, limit is 4. So
Կարող ենք այդ squeezing գրել մի հատ։
a squeezing again. Okay. Yn over n. Do you agree that it is less than yn with module yn is less than 5? So do you agree that this part is correct?
5 over
From below, do you agree that yn is greater than minus 5?
Oh, okay.
It tends to 0, tends to 0. Remember, any bounded sequence divided by n squared, divided by infinity, always tends to 0. The next one says yn plus xn is bounded. Yes, yn is bounded, it's given. Xn is xn bounded, guys?
Yes.
Yes.
Ինչ կասեք, մոդուլ xn ինչ ծա փոքր։
Forces.
Ճիշտ է դա։
կարող է բանից չեմ գրել։ Հա, ուտի որ 4-ից։
Հա, որ։
Կարող է աչից է, թե ինչ
Կարող։
բան։
Այդ երևի չենք կարասենք, բայց
Ճիշտ է։
ընդհանուր ինքը convergent է, ուրեմն
Այո, դա է
bounded է։
ճիշտ պատասխանը. So the correct answer, okay, we don't know what is upper bound, but for sure xn is bounded. If it tends to 4, it is bounded. Any convergent sequence is bounded. We don't know what is upper bound. It depends what is x1, what is x2, what is x3. Maybe xn starts from 1000 and decreases to 1. Then it is smaller than 1000, but we don't know the behavior of xn. But for sure it is bounded. Bounded plus bounded is bounded. Hence, the correct answer is D. Because once again, yn over n tends to 0. Even though that yn is divergent, but divided by n is convergent. Two 2023 multiple choice number 7. Find not odd function. Okay. Is this odd?
Yes.
How we can check, guys? Just plug instead of x minus x. Minus x over module x plus 1. So it is the same as minus f of x. So minus f minus x equals to minus fx. It is odd. Maybe this one is not odd. As in chart. F minus x is 5 minus x minus 5 minus x, so just plus x, divided by x squared plus 3. It is nothing else than minus f of x. Maybe this is not odd function. Let's discuss it here. What is f minus x? It is minus x cubed plus 1. And here we go. This is not minus fx. This is not minus x cubed plus 1 like this. Because we have plus 1, not minus 1. So E is not odd. If you prefer, you can think about this way. Odd function divided by even function is odd. Odd function plus even function is not odd, neither even. Here we have x cubed plus 1. If instead of plus 1 you have here written any odd function, then it will be odd. Odd plus odd is odd. But odd plus 1 is even function. Is not odd. Questions?
Բին մի հատ է կբացատրեք, որ խնդրեմ։
Just plug minus x instead of x. And we will get f minus x is, I'm just writing minus x instead of x. And minus x squared is the same as x squared. And we said this is the same as minus f of x. Okay, what if minus fx, stashma stech minus, stech plus. So 5.
Ավայ, այնտեղ ինգիրը ավայ լավ։ Ուշադրի չի լավ։
It's okay. Okay.
I'm sorry, could you explain why 1 is even?
Okay. Function f of x constant 1 is even or odd. To understand this, we have to plug instead of x minus 6. What is going to be f minus 6? Again 1, right? Because
1
it is
again,
constant 1. So it is the same as f of x.
Oh,
If
okay,
f
thank
minus
you.
6 is fx, it is odd. It is even, sorry. 2018, okay, 2022 multiple choice number 5. 22 multiple choice number 5. Okay, so we have given some sequence and somewhere here is written constant c, some parameter. And we have to identify this parameter for which the limit here will be 1/2. To find c, guys, I would suggest just to open this squared. We have 5 plus 2 times 4n plus n 100 divided by opening squared, like parentheses. We will get c squared. 2n squared. 2n squared is the same as 4n. Okay?
Yes.
Plus 2 times c times 2n times n 50 and plus n 100. Find fastest term.
4 in a power of n.
4 to the power of n. Right. And when you have 4n fastest term, dividing by 4n, since this is not show work problem, we can do it like faster. Writing 2 divided by c squared is going to be the limit, right? Because the rest are less. They are slower than 4n, for sure. Even this one. Okay? 2n times n50 divided by 4n. Actually, this is n50 over 2n, which tends to 0. 2n is faster than n50. For which c, 2 over c squared is 1/2. What is c?
Minus or plus 2?
Right? And we have here such option. The exercise is not saying find all possible values of c. It says find value c for which the statement is correct. Huh? C equals to 2 also will work. 2022 multiple choice. Okay, show work number 4. 2022, this test. Show work number 4. Okay. Help me. How we can find limit?
Squeezing.
Squeezing. Okay. How many terms are written here, guys?
1
2n.
minus 1.
2n or 2n minus 1?
2n minus 1 since it starts from 2.
Yes, we are starting from 2. Like this is the first term. Here we have the second term. The number of term we can understand it is this constant subtracted 1, right? Or we are starting from 2, we are moving to 2n, we have 2n minus 1 terms. It's important because the rest is to estimate all terms if we are denoting this by xn. What is estimation from above? We have to choose the largest term, which is term with smallest denumerator, the first one. And as we already said, we have 2n minus 1 terms. We'll get 2n minus 1 divided by root of 4n squared plus log n plus 2. Divide by n. 2 minus 1 over n divided by expression under the root. We can divide by n squared, right? It's the same. We'll get n over n squared plus 2 over n squared. And it's straightforward that the limit here is what?
1/2.
Okay, 1.
1.
Just 1. And doing similar stuff from below, we have 2n minus 1, and now choosing the largest term. Largest denominator, sorry. 4n squared plus log n plus 2n. And again, dividing by n, 2 minus 1 over n divided by root of, under root, we are dividing by n squared, log n over n squared, and then we have 2 over n. The only difference is that above we had 2 over n squared, now we have 2 over n, but the limit is the same one. Questions?
Այդ երկուին մինուս 1-ը ոնց եք որոշում, մի հատ եք ասեք։
How many now? So first term, the only difference between all these terms is this part. So here, imagine we have 2, then we have 3, then we have 4, then we have 5, then we have 2n. How many numbers are written here? If you have step here is 1, from 2 to 3, 3 to 4, 4, 5, etc., you can just take the last term, 2n, minus the first term, plus 1. Then saying Chanum. Or another approach, like here is the first term, here is the second term, then third term, fourth term, which term is the last one? From 2 we are subtracting 1. From 3 we are subtracting 1, so from 2n also we should subtract 1 to get corresponding term number, 2n minus 1. But yeah, how many numbers we have from 2 to 2n? Just 2n minus 2 plus 1, 2n minus 1. How many terms we have from k to
2n minus 1?
To m? How many terms are written here? From k to m.
M minus K plus 1.
Yeah, thank you. M minus K plus 1. Okay. Okay. 2021 multiple choice number 9. Again, not relevant, but what is the limit? Can you say what is the limit of this?
-1.
X tends to 0. So do we have here limit
So we
1
need to
of...
find it from two sides.
So far, side is not important, but having 3 to the power 1 over x, it is 3 to the power of infinity, right? If x tends to 0, 1 over x tends to infinity. What is 3 to the power of infinity?
Infinity.
It depends. It depends which infinity do we have. Is it 3 to the power of plus infinity? Then yes, you are right, it is infinity. But what if we have 3 to the power of minus infinity?
It tends to 0.
Yes, in this case it will be 0. So it depends which case do we have here. If we have here 3 plus infinity is infinity, then it is 0. But if 3 to the power of infinity is 0, we will get -1. So -1 or infinity? -1 or infinity? -1 or infinity? Maybe we can choose 0. Watchmaker, watchmaker. Huh?
No, it doesn't exist.
Yes, limit doesn't exist. Because from right side, it's going to be infinity, or from the other one, it's -1. So limit doesn't exist. Okay, that was, again, very important, but for midterm number 2. 2017. Multiple choice 8 and 10. Skip it. Again, we will discuss it maybe next time. Related to functions, continuities, limits. Some exercise about composition of now 3 functions f, g, h. We have to pick 3 functions such that the composition gives exponential x squared minus 1 under the root. Let me just try the last one. So what is going to be f composition with g, composition with h? First, h of x should be plugged into g. We will get f root of x minus 1. Root of x minus 1 should be plugged here, and we will get e to the power of x minus 1. Is this correct answer? No, it is not.
عن الأسهل.
What if it is root of x minus 1? We are going to get -1 at the end. It is not. Same. Okay. Vormeka portsing.
See?
So,
Okay, let's check this here. F g at x squared. So it is f at gx squared is e to the power of x squared minus 1. What is f is root ex squared minus 1. So C is the correct answer. Okay? Do slowly, step by step. Write H, plug into G, get the result. Plug into F and compare with our given capital H. So here, the fast way to solve this was beginning with statement number C. Okay, now comes to getting C. Shortcut is statement number C. 2024 multiplication number 10, number 10, please. Eriksen Areling. 2022 show work number 3, please, please, please. Okay. 2022 show work number 3. Okay, let's do it. Okay. So we have to find limit of this. If we pass to the limit, guys, what do we get when n goes to infinity? What is the limit inside of brackets? N factor minus 2n, n factor minus 4n squared. Which term is the fastest one?
N factorial and the limit
Right.
is 1.
So we'll get 1 to which power?
Infinity.
What is 1 to the power of infinity?
Indeterminate form.
Indeterminate form, right. So, and we can remember the useful limit saying that 1 plus 1 over n to the power of n tends to e. In particular, we can think of 1 plus, for example, 1 over xn taken to the power of xn tends to e as xn goes to infinity. So we can apply this if xn goes to infinity. Okay? Just infinity, no need even plus infinity. Just infinity is fine. Now let's create this 1 plus term. If we do not see how we can make it 1 plus term, let's add and subtract. So we have n factorial minus 2n divided by n factorial minus 4n squared. Let's write minus 1 and plus 1. Taken 5n minus 1 factorial over 3n. We write it as 1 plus, bring into common denominator the first two terms. We'll get n factorial minus 4n squared and n factorial minus 2n minus n factorial plus 4n squared taken 5n minus 1 factorial divided by 3n. Okay. After simplification, we get 1 plus 4n squared minus 2n divided by n factor minus 4n squared. Useful limit says that we have 1 plus 1 over xn taken to the power of
n factorial minus 4n քառակուսի բաժանած
բաժանած
4n
4n squared minus 2n. This term tends to e. But the power, of course, previously given is not that. Was 5 times n minus 1 factor over 3n. Let's make it equal to it. So
անգամ դրա հակառակն է
correct. This is multiplied. Okay. And times 5n minus 1 factorial divided by 3n. Let's focus only on this part, for instance, and let's find the limit of this part. Huh? So let's consider limit of, so we have 4n squared minus 2n multiplied with 5n minus 1 factorial divided by, what do we have? We have 3n times n factorial minus 12n cubed.
Can we find fastest terms?
Which one is the fastest term?
N factorial.
Say again.
N factorial.
Say again, but correct.
3n times n factorial.
Okay, but 3 is not relevant, just n times n factorial. N times n factorial. Okay. Numerator 4n squared minus 2n times 5. We are dividing by n factorial times n. Do you agree we will get just n times another n? N minus 1 factorial over n factorial gives 1 over n. So we have this on numerator. 3 minus 12n cubed divided by n factorial. What is the limit of this part? 0. Correct.
0.
What is the limit of this component?
4.
5.
20.
20.
Overall limit here is what? 20 divided by 3.
E to the power of z.
Yeah, now going back. I calculated this limit. Now going back, our exam.
Եթե 3n n-ի ֆակտորիալի վրա բաժանենք, նույն պատասխանը կստանանք։
Անպայման, այո։ Իրական նայեք, որ 3-ի բաժանենք, ստեղ կլներ 3, ստեղ կլներ 1. Ստացվեց 20 over 3 divided by 1.
Okay.
So at the end, we get that xn tends to e to the power of 20 divided by 3. Okay. Next question, 2022 multiple choice number 2. How many of the following limits are not indeterminate forms? First one, so pay your attention. We are not asking about limits of some expression. We are asking about forms, indeterminate forms or determinate forms. So which form do we have for the first limit?
1 in the power of infinity.
Is this indeterminate form?
Yes.
Yes. What about the second one? What is this? 1 over n plus 1 goes to 0. Power is 0. 0 over 0. Indeterminate form?
Yes.
Next one, infinity over infinity. Right? What is here?
Sinus 1 divided into n, it does not exist.
Why
0
not?
over infinity.
0 over infinity. Is
And
this
it's
indeterminate
0.
form?
No, it's 0.
It's 0.
So far we have one not indeterminate form. What about the last one?
It's 1 over, no,
Infinity over infinity.
Why?
Just
It
0
goes to
plus 0
zero.
plus
No,
0.
What
it's
is
0.
what is the limit of 1 over n?
Zero.
0.
Second term.
Yeah.
Again 0.
Also 0.
How many such zeros do we have?
10.
10.
10. 0 plus 0 plus 0, 10 times. Is this indeterminate form?
No.
No. So we have two examples of not indeterminate forms.
Can I ask a question?
Please, please, please.
Is there is there an option or a situation where the sum of zeros is not 0?
How many terms do you have in your sum? This is the key point. Huh? If you have
Okay.
10 elements, then 10 zeros gives 0.
So like if we have infinity or n terms?
Exactly. This is the point. When we have n terms, like n plus n times 1 over n, we have 1 over n plus 1 over n plus 1 over n. And here we have n such 1 over n's. This is just n over n, 1. And it gives not 0, it gives 1, because it is always 1. If you have here not to the power of 10, but you have n to the power of n, then this exercise will be, the finding limit will be tough. Is it indeterminate form? No, it's not indeterminate form. But it is, the calculation of limit is not obvious. Maybe squeezing theorem is needed. Maybe, I don't know, something else, telescopic is needed, but it is not, sum of zeros is not indeterminate form. Maybe infinite sum of zeros, yes. In this case, that was sum of 10 zeros.
Okay, thank you.
Look. 2017 multiple choice number 3. Limit of functions, again, not relevant, but what is the limit of sinus x over x?
1.
1.
When x tends to 0, 1. What is the limit of function f when argument tends to 1?
2.
2.
The main question here is like when the argument when we have some expression inside the argument part, we at first calculate the limit of that and then transfer the x argument x tends to that limit and then
Yes. First we are calculating what goes on with the argument of function f. It tends to 1, then looking to this property given. Yeah.
Okay, thank you.
2024 show work number 4. It's quite similar to the previous exercise that we have discussed.
Plus 1 minus 1.
Plus 1 minus 1. Yeah, it's again 1 to the power of infinity form. And our xn, this is xn, can be written as 1 plus 2n plus 7n, 2n plus 7n plus 1, minus 1, right? Bringing into common denominator, we'll get minus 2n. In this case, actually, we can... Do you agree with this? 2n plus 7n over 2n plus 7 gives 1. So it remains this.
Yes.
Will be nice to have power 2n plus 7n. Okay, let's create it. Multiplied with 3 times 4n plus 5n squared divided by 7 times 2n plus 3 is multiplied with 2n plus 7n. What is the limit of this component?
3/7.
Yes, just opening brackets, we will find 7 times 4n. So final limit is 3 e to the power of 3/7. Okay. Step մի քիչ արագ արեցի, open brackets and verify that limit is 3/7 by dividing 4 to the power of n. Mhm. 2022 multiple choice number 9. Find divergent. Is this divergent?
No.
What is the limit of it?
0.
Yeah, argument tends to 0. Sinus of 0 is 0. So it tends to 0. N squared plus 1 over 3n over n cubed plus 2n also tends to 0. So the first tends to 0. It is convergent. What about B? What is the limit here? It is the same. 0. What is the limit here?
Infinity.
0 plus infinity is infinity.
And it's divergent.
So it is divergent. The rest convergent. 0 plus 0. Here again 0. This tends to cosine pi half 2. What is this, guys?
It is 2.
ID and the root.
It's j. Minus 1 to power 2n. It's
Is
always
1.
1. Yep.
C-ի առաջինն էլ մի հատ կասեք։
Yeah, squeezing.
Okay.
Okay. In this 2022 multiple choice number 6. Not one-to-one function. We have same parabola written here. What is graph of this parabola? We have to identify roots of this parabola, of this quadratic equation. What's our roots of this function, guys?
-3, 2.
-3.
-2.
And -2. Yeah, it seems -3 and -2.
Mm-hmm.
So the graph is something like, sorry. Something like this. Okay? Is it one-to-one from 0 to infinity? Is this part one-to-one?
Yes.
Yes.
Yes. Below 0, is it 1 to 1?
No.
No. So we found
Բայց ճիշտ ենք գրել։
հակառակապտյանենք, չէ?
Ահա։
So our goal was to find not 1 to 1. The rest are 1 to 1 functions. For example, sinus function is something like this, and here from minus pi half to pi half it is 1 to 1. Cosine from 0 to pi, again think graphically here. From 0 to pi, point pi is here. This part is 1 to 1. Sinus from 0 to pi over 4 also is 1 to 1, of course. So that's only D is not 1 to 1. Okay. What do we have else? 2019 multiple choice number 3. Limit of functions with some sequences, again, not so relevant here. Let's skip this and discuss next time. 2018 multiple choice number 5. What is the limit of this expression, guys? N factorial 2n, n18, 2n. Which is the fastest term?
Any factorial?
Okay, so what is the limit?
Converge, infinity.
Infinity. N factorial goes faster than n18, 2n, so yeah, it's infinity. 2024 multiple choice number 8 and 7. Twenty-four. Eight. The limit of sequence an is 1. Which of the following statements is true? The number of terms of sequence an that are smaller than 1 is infinity. Can we say it is true? If sequence an tends to 1, can we say that the number of terms of an that are smaller than 1 is infinity?
Չէ, որովհետև բոլոր թվերը մեկի կողքերն են հավաքվելու։
Հա, ու չգիտենք որ կողքերը, աճից թե ձախից, չգիտենք. An tends to 1, maybe from right side, maybe from left side. Maybe our sequence tends to 1 from this, and we do not have any single term of an less than 1. And the same with bigger 1. Maybe we are approaching to 1 from the right side. Huh? That are smaller than 0 is infinity. Sequence tends to 1. And here is 0. It says we have infinitely many terms less than 0. No, it is not correct. It's not correct because sequence tends to 1. It cannot be the case when we have infinitely many terms less than 0. Smaller than 2? Yes, of course. Now, this one is smaller than 2 because we have infinitely many elements in any neighborhood of 1. Choose some neighborhood of 1 that is less than 2. Then we have infinitely many elements in this neighborhood, so less than 2. Bigger than 2? Of course, no. Bigger than 0? Yes, infinitely many elements are bigger than 0. Okay? Number 7 from the same year. F is even and its image of the interval of -1 to 1 through function is -2 to 2. What can we say about F01?
the range need to be the same?
Yes, because function is even. So it have to be, it should be minus 2 to 2, okay? Because range from 0 to 1 and from minus 1 to 0 are equal, and so it should be from minus 2 to 2. So we found the correct answer. The rest, yeah, all other options, it should be from minus 2 to 2. Questions? The last one, 2024, okay. 2022 multiple choice number. Let be given the following sequences. We have here 4 sequences. Which of the following sequences are decreasing? Okay. What are it? The first one, xn is 2n minus 1 over n. What is x1?
One.
What is x2?
3/2.
Is it possible that our sequence is decreasing? No. Minus 1n over n is like this. 1 negative, 1 positive, negative, positive, negative, positive, negative, positive. So it is not increasing, neither decreasing. What is the limit of 0.2 to the power of n minus 1? Or what is the behavior of this number, of this sequence? It is 1 over 5. It is 0. It's 1 over 5 to the power of n minus 1. Okay? 0.2 is 1/5. Do you agree that 5 to the power of n minus 1 is increasing? It is hypocranoma. What the 5 to the power of n is increasing, 1 over increasing is decreasing.
No,
And chores, yes, chores decreasing, obviously, yeah, minus n squared. Okay, guys. I think we are done. If you have more questions, you are welcome to ask your questions during our Friday sessions. We are going to have other problem solving sessions scheduled for tomorrow, maybe for Friday. So please collect more questions and let's discuss these questions tomorrow and Friday. Moreover, if you wish, we can have extra office hours on next Monday and discuss your questions next Monday. Okay?
Okay, thank you.
Thank you.
Thank you, guys.
Thank you.
Ինչ խորտ կտա կանենք
Thank
բացի
you.
թեստերից։
Homeworkները.
Yeah.
Revise homeworks also will be quite useful.